And now we're going to begin with proofs. Now, there are three methods of proving something true in geometry that we will be talking about. We will be talking about T-charts, paragraph proofs, and flowcharts. But regardless of which method you use, one of the most important things to be doing is to plan your proof beforehand. If you spend a few minutes planning the proof beforehand, you can save yourself a lot of time and effort later on. So that's what we're going to do now. So first of all, in a proof, you are normally given some information at the top. So here there's two different forms of information the way they've given it to you. So the given information means the information they're literally giving to you to be able to solve the problem. So here we have angle 1 and angle 3 are vertical angles. So that's in written format. Now, quite often, you will also have a picture that goes along with it. Any information that's in the picture or in the words is information that you are allowed to use in the proof. Now, sometimes the information in the words is information that you can figure out from the picture if you know certain definitions and theorems. And sometimes it's not. But in this case, they're telling us that angle 1 and angle 3 are vertical angles. It's the angles that are straight across from each other. Now, we already know that from the vertical angles theorem, but we're going to pretend that we don't know that theorem. So the only thing we do know is the linear pair theorem. So we know what linear pairs are, and we know what the theorem says. So the linear pair theorem says that two angles that form a linear pair are supplementary. Okay, so we want to plan this proof, and I'm going to look at the picture. We know that we're going to try to show that these two angles are congruent. They're equal to each other in measure. Now, what we do know is we have four angles that are formed by these two intersecting lines. And we know something about these two, any two of these that are adjacent. So angle 1 and angle 2 form a linear pair, and angle 2 and angle 3 form a linear pair. I'm going to start writing down what we know first of all. Angle 1 and angle 3 are vertical angles. We know that because that's our given information. Now in this case, we're not allowed to use what we know from the theorem about vertical angles. We're going to prove the theorem, and then we can use that later on anytime we want. But for now, we're not allowed to use that. So this is just information that we're going to then prove something that's true about this. So the second thing is what we know about the linear pairs. So we know angle 1 and angle 2, they're adjacent. They form a linear pair because those two lines, those two angles share a side, and the other sides of the angles form a line. So angle 1 and angle 2 they form a linear pair. And the same thing is true for angle 2 and angle 3. They also form a linear pair. Now, of course, we could go on with 3 and 4, but what I'm looking at is that we have angle 1 and angle 2. That's 180 degrees. Now, also notice that if we continue on around like this, on that side, we have angle 2 and angle 3. And the significant part about this is that they overlap. so that angle 2, that angle, is shared by both of these linear pair. So it's angle 2 is in this linear pair, and it's also part of this linear pair. So we're going to use that to help us out, because whenever you have something in common, it gives you a link that helps you compare things. So we know that the measure of angle 1 plus the measure of angle 2 has to be equal to 180, because, well, it's a linear pair. That means they have to be supplementary. So we know that's true. We also know that the measure of angle 2 plus the measure of angle 3, that also has to be equal to 180. Now, when we put these together, we notice that's the same, right? Okay, so angle 180 and 180, we have something that they have in common in addition to the angle 2. So I'm going to write it out like this over here. So I'm just going to rewrite the same thing, but put it together and write it in a slightly different way. I'm hoping that this will make it easier to see what's happening. So when I turn this around, notice, the equal sign, it doesn't matter what side of the equal sign 180 is on, we can put on either side. So on this one, I'll keep it the same way. And the other one, I'm just going to replace it. So we have measure angle 2 plus measure angle 3. So we have measure angle 1 plus measure angle 2 equals 180. 180 equals measure angle 2 plus measure angle 3. Now, if we consolidate this, if we put it together, this is what we have. Okay? So this part right here is the same as that. It's the same as that. And if we eliminate it, these two are congruent as well. Or equal, I'm sorry. So measure angle 1 plus the measure angle 2 equals the measure angle 2 plus the measure angle 3. So this is something that's called the transitive property. So if we have two things that are equal to the same thing, we can say those two things are equal to each other. That's the transitive property. Now, what's significant is now we can see, just like we saw up here, measure angle 2 and measure angle 2, it's shared, it showed up twice. It showed up twice here, and it's on both sides of the equal sign. So if we subtract measure angle 2 from both sides, that is 0. So we won't have it anymore. Measure angle 1 is going to be equal to measure angle 3, which means angle 1 is congruent to angle 3. That would just be by the definition of congruence. So if the measure of two angles is equal to each other, then those two angles are congruent. So that's our plan. So in order to write the proofs, we just have to follow this order and just write it in a specific format depending on the type of proof that we're going to write. So we'll use this plan later on in the next few videos.